Deep in Colombia's cerrejon region, scientists and paleontologists were excavating a vast coal mine. At first glance, the site appeared to be nothing more than an industrial landscape carved open for fuel. But beneath the surface lay something far more extraordinary. This coal mine existed because, nearly 60 million years ago, the region had been covered by one of Earth's earliest tropical rainforests. Layer by layer, time had sealed away the remains of an ancient ecosystem, preserving fragments of a world long gone. The researchers working there were not searching for monsters. Their primary goal was to study fossilized plants and reconstruct what prehistoric rainforests once looked like. However, during one excavation, something unexpected emerged from deep within the rock. As the surrounding soil was removed, a strange fossil appeared. It was clearly organic, yet its identity was unclear. Some experts believed it was a crocodile bone. Others suggested it belonged to a turtle, while a few thought it was part of an ancient tree trunk. This creature was unlike any snake alive today. It was not simply longer than modern snakes. It was massively heavier, stronger, and more dominant. Compared to today's green anaconda, Titanoboa was nearly 10 times heavier and significantly longer than a passenger bus. Its size alone raised an impossible question. How could a snake of such enormous mass even survive? If such a creature attempted to live entirely on land, its own weight would work against it. Gravity would crush its body, making movement nearly impossible. This led scientists to ask a deeper question. Where did this giant live, and how did it move? The discovery of Titanoboa did not happen overnight. The story began in 1994 when a local geologist named Henry Garcia noticed an unusual fossil in the cerrejon mine. It resembled a thick branch or tree limb, and at the time, no one suspected it belonged to an animal. The specimen was stored and largely forgotten. Years later, in 2002, another geologist, Fabiani Herrera, uncovered a similar fossil in the same mine. Once again, it was catalogued without much excitement. Both discoveries occurred while scientists were studying Paleocene-era plant life, trying to understand how Earth's earliest tropical rainforests developed after the extinction of the dinosaurs. The turning point came in 2007, when these fossils were sent to the Florida Museum of Natural History for closer examination. There, experts realized the specimens were not plant material at all. They were vertebrae. At first, scientists considered the possibility that the bones belonged to a crocodile, but detailed analysis ruled this out. When the vertebrae were compared to those of modern snakes, including anacondas and pythons, the results were astonishing. The fossilized vertebrae were nearly 3 times thicker and larger than those of today's biggest snakes. There was no doubt left. These bones belonged to a snake of unprecedented size. Using mathematical models, researchers began estimating the creature's total length. In snakes, vertebra size closely correlates with body length. By applying these models, scientists concluded that Titanoboa measured between 42 and 50 feet long. That made it roughly twice the length of a modern anaconda. But length alone did not capture its true scale. Titanoboa's body was extraordinarily thick, with a girth comparable to a large adult human's waist. Its estimated weight reached approximately 1,200 kilograms, similar to a small car. Such mass is unimaginable for any land-dwelling snake today. This discovery sent shockwaves through the scientific world. Titanoboa was not just the largest snake ever known, it was the apex predator of its time. The most important question, however, was not how big Titanoboa was, but why it grew so large. Snakes are ectothermic animals, meaning they depend on external heat to regulate their body temperature. Unlike mammals, they cannot generate internal warmth. The warmer the environment, the more efficiently a cold-blooded animal's metabolism operates. Faster metabolism allows for quicker growth, greater energy, and the ability to sustain a larger body. Titanoboa's size became indirect evidence of the climate it lived in. Scientists realized that for a snake of such enormous mass to survive, the surrounding temperature must have been extremely high. Studies suggested that 60 million years ago, average temperatures in the region exceeded 32 degrees Celsius year-round, with little variation between day and night. Humidity levels would have been extreme, creating dense, steamy forests and vast swamp systems. This constant heat provided Titanoboa with the energy required to grow and function. Ironically, today's Amazon rainforest, which feels oppressively hot to humans, would likely be too cool for Titanoboa to survive. Such a massive body demanded a specialized lifestyle. Titanoboa was not a fast-moving land predator. On land, its size and weight would have made movement inefficient and exhausting. Instead, it was perfectly adapted to life in water. Titanoboa spent most of its time in swamps, rivers, and marshes. Water supported its immense weight, reducing strain on its internal organs and allowing it to move with surprising efficiency. In this environment, it became an ambush predator, much like modern crocodiles. Hidden beneath murky water, Titanoboa would remain motionless for hours or even days. Only its eyes and nostrils broke the surface. When prey approached the water's edge, the snake struck with sudden and overwhelming force. Biomechanical studies estimate that Titanoboa could exert over 400 pounds per square inch of constriction pressure. This was enough not only to suffocate prey, but to crush bones and instantly stop blood circulation. Death came within seconds. Its prey included giant turtles and massive prehistoric crocodilians. Some turtles of that era reached lengths of over 8 feet, protected by thick shells. Titanoboa's powerful jaws and teeth were built to withstand and crush such defenses. For years, scientists lacked a crucial piece of the puzzle: the skull. Snake skulls are composed of delicate bones that rarely fossilize intact. Without it, understanding how Titanoboa fed remained difficult. That changed in 2011 when a remarkably well-preserved skull was discovered at Cerrejon. This find confirmed that Titanoboa's jaws could dislocate, allowing it to swallow prey far larger than its head. Although its brain was relatively small, its sensory systems were highly advanced. Heat-sensing organs enabled it to detect warm-blooded animals even in complete darkness. Despite its perfection, Titanoboa's existence depended on a fragile balance. Heat fueled its metabolism, and water supported its massive body. When Earth's climate began to cool after the Paleocene epoch, that balance collapsed. Even small drops in temperature slowed Titanoboa's metabolism. Digestion became inefficient, energy levels declined, and hunting success dropped. Swamps began to dry out, removing the aquatic environments it depended on. At the same time, mammals diversified and competed for resources. With less heat, less water, and increasing competition, the world's largest snake could no longer survive. A few degrees of cooling were enough to erase a giant from existence, leaving behind only fossilized bones buried deep within the earth.